In this video, we are going to solve a problem which is going to be very important if you want to understand binary search and you want to identify the problem related to binary search and apply it effectively. We are going to change the entire perspective that we have on binary search by solving this problem. Okay, let's look at the problem statement. We need to find the maximum value in an array that has first increasing and then decreasing numbers. That means array of x is less than array of x plus 1 till index k. Some index k. We don't know what that index is. After that, we have array of x is greater than array of x plus 1. Condition is reversed, see. That means you have increasing value and then decreasing value. And this index is going to be kth index. And we need to find this value. So in the given example, look at this 1, 2, 8 and 12. This is increasing. After that 12, 5 and 3 is decreasing. So the maximum value that we have is 12. Correct? Similarly here, we have 100 increasing. After that 8, 6, 5, 3 decreasing. And this is where our answer is 100, the largest value. So this is what we need to find. So the very first approach that comes into our mind is that let's iterate from left to right and find the value. Simple, right? It's just going to take often time. We are going to iterate from left to right and we find the value which is the largest. Simple. But that will take often time. Earlier we saw, rather than saying, can I sort the input? We are going to ask the question, can we define a function f of x such that the f of x will change value only once? Can I define a function? Think about it. Is there exist a function that I can define so that I can transform this array into zeros and ones and the shift from 0 to 1 will happen only once. That means the value will be changed only once. Can I define a function like that? Well, it's simple. By looking at the condition, we can clearly see that we can define a function. So what that function is going to be? See, what we want? We want 0 here, we want 0 here, we want 0 here. We want 1 here, we want 1 here, we want 1 here. Why do we want 1 here? Because this index is going to have the answer. So I can define a function if my value, let's say my value for this x is greater than x plus 1, then I will say it's true. Otherwise I will say it false. Simple, right? Here, look at this. Value of 1 greater than 2? No, then it's going to be 0. Value of 2 greater than 8? No, then it's going to be 0. So this is how I will define my f of x. Once I define my f of x like this, I know that this will become 0, this will become 0, this will become 0. Why? Because all of these numbers are going to follow this pattern where array of x is less than array of x plus 1 till index k. That index here is 3, right? Till index 3, everything is going to be 0. After that, every single element is going to follow this property. And that's what we have defined here. So we get 1, we get 1, we get 1. Correct? Array of x is going to be greater than array of x plus 1. So 12 is greater than 5, 5 is greater than 3. Now if I apply binary search on this array to search for the very first occurrence of 1, then we can definitely see that it's going to be index 3. And that's where our answer is. Let's look for the second example as well. So it's going to be 0, it's going to be 1, 1, 1, 1 and 1. Correct? This is our f of x. And here we will have 1. Again I will apply binary search on this particular array. And what I will get? I will get index 1. And index 1 has 100. And that's what my answer is. Very, very simple, right? So if you think in terms of binary search, well, you never be able to solve this problem. Why? Because in binary search what we say is array sorted. Well, it's no. Then you cannot apply binary search. But remember, we changed our thinking. We changed our perspective. Now, we are not asking about is the array sorted or not. What we are asking ourselves that can we define function f of x that is going to change the value only once? And yes, we can define a function that is going to change value only once. What is that function going to be? Well, we have already seen that. It's going to be f of x is equal to array x greater than array x plus 1. Now this function will convert our input array into array something like this. Now look at the process on how exactly we are going to develop a function. See, what we want, when array x is less than array x plus 1, we want false, that means we want 0. And when array x is greater than array x plus 1, we want true. But what about the final index? There is no x plus 1 for it, right? Well, we are going to define, if x plus 1 is going to be n, then we will define it as true. So we have 0, 0, 0, 1, 1, and we don't have x plus 1, but x plus 1 is going to be equal to 1, n, so it will be 1 as well. See, our f of x should convert the input array into zeros and ones, and the value will only change once, and that particular index should be our final answer. That's how we are going to define our f of x. What are the conditions? First one, only zeros and ones. That's the first condition. What is second? The change from 0 to 1 should occur on the answer index. These two are the main conditions to define f of x. And we managed to define it in this way. And this will convert our array into zeros and ones. And now we can apply binary search on this and get the very first occurrence of 1, that is going to be index 3. And index 3, we can check what is the value on index 3, that is going to be 12, and 12 is the largest value we can have. So the whole point is that in a traditional binary search, we first think whether the input array is sorted or not. If not, then we don't apply binary search. But here we can clearly see we can convert the input array into something on which we can apply binary search. So these are the steps we have already seen. Can I define the function f of x which changes value only once? That's the first question that we are going to ask. Then we are going to write divide and conquer code in binary search style. We will use high and low pointers to track our search space. So let's write the code. See, this is exactly binary search code. And we are going to define our condition here. If our mid value plus 1 is going to be n, then it's going to be true. We have already seen, right? That's how we have defined. If x plus 1 is equal to n, then we are going to return true. Otherwise, this is the OR condition, right? If this is executed and it returns 1, and because of OR condition, the RHS will never be executed. If it's 0, then only RHS will be executed. That means we will have mid and we will have mid plus 1. And we are going to pass it to the function f. And if it is 1, then we are going to search on the left side. We have already discussed why we search on the left side. See, this mid could be a potential answer, but we want to find the very first occurrence of 1. That's why we need to go to the left. And we update the high pointer to search in the left portion, right? Let's define the function f. We have already seen, if current value is greater than the next value, then we are going to return true. Otherwise, we are going to return the false. This is what we have defined here, right? If array of x is greater than x plus 1, then only we are going to return true. So by solving this problem, we managed to change our perspective on binary search and how we execute it. Remember, whenever you see a searching problem and there exists a pattern of the elements in the input array, then most probably we can write a function f of x which will convert our input array into array of zeros and 1 where value will be changed only once.